Welcome to Elimu TV. This is mathematics lesson for Form 3. My name is JP Kamau, and I will continue from where we stopped in previous lesson. And we are dealing with quadratic equations and expressions. And expressions. So in dealing with this, you remember a quadratic expression is of the form ax squared plus bx plus c, where a, b, and c are constants. Now, we also talked about how to determine each of these. For example, we can have 4x squared plus 16x plus 3. That is a quadratic expression. And then we also said that we have quadratic expressions that are perfect squares, in that they can be written in the form a plus b squared. For example, if I say x plus 2 squared and multiply this out, I will have, let me write it up here, x plus 2 squared means x plus 2 multiplied by x plus 2. And this is how we multiply: x multiplied by x, then multiply by 2. Then 2 multiplied by x, then multiply by 2. So x by x gives you x squared. Then x by 2 gives you plus 2x. Then 2 by x plus 2x. And then 2 multiplied by 2 gives you 4. We now combine this so that we have x squared plus 4x plus 4. So this is what we are referring as a quadratic expression. Now this quadratic expression is a perfect square. It's a perfect square because it can be written as the square of x plus 2. X plus 2 whole squared is equals to x squared plus 4x plus 4. Now, we also talked about how you determine if you are given 16a squared plus dash plus 9, and you are asked to determine the middle term, MT, standing for middle term. The middle term. Then, for a perfect square, we said that the middle term is equals to 2 times the square root of the first term, which is 16a squared, multiplied by square root of the third term. So I'm going to be using initials for middle term. I'll call it MT. Then first term, I'll call it FT. And then the last term, I'll call it LT. Last term. So we have middle term, first term, the last term. Now, the term that has the variable squared is the first term. Then we have the middle term, which is also the linear term. and this is the constant term or the last term. So how do we determine the middle term for this one? We said the middle term is equals to 2 times the square root of the first term multiplied by square root of the last term, which therefore will be 2 times square root of 16a squared is 4a. And then multiply by square root of last term. Last term is 9, so the square root is 3. And when you multiply this out, you get 24a. And therefore, the number that we should fill here is 24a to make it a perfect square. So middle term, remember middle term is equals to twice square root of first term multiplied by square root of last term. Similarly, we can say that by dividing throughout by 2 divide by square root of last term, we can say square root of first term will be middle term divided by 2 times square root of the last term. And so to get the first term, we say squaring both sides. If we square both sides, we will have the first term is equals to middle term squared divided by 4 times the last term. So this is very important. Let me write it here. The first term is equals to middle term squared divided by 4 times the last term. And then I'll just give this one straight away. The last term is equals to middle term squared divided by 4 times the first term. So these are what we are going to use to discuss today's lesson, which is completing the square. Today we are going to be thinking about completing the square. Now, what is completing the square? This is the process of adding the third term to the first and second terms to make a perfect square. You may be given an expression that does not have a third term, and you're required to determine what is the third term that needs to be added. What number should we add to make it a complete square? For example, you have x squared plus 2x, and you are asked to find the third term or the last term, or what should be added to this expression to make it a perfect square. A perfect square means it can be written as a certain number there, whole squared. So now there are 2 rules. The first one is if the coefficient of x squared, is 1. If coefficient of x squared is 1, then we need to add you are told add half the coefficient of the middle term squared. Now, let me use this example to explain. What number do we need to add there? We need to add, this is the coefficient of x, or the middle term, which is positive 2. So that we need to add the square of half of this. So we will say half of 2 whole squared is what we need to add, which will come to half of 2 is 1 squared, which is equals to 1. So that means if we add 1, that becomes a perfect square. And what is it a square of? Remember what we said, product and sum. We need to factorize this. So using the method of product and sum, we will say the product will be 1, the sum will be the coefficient of the middle term, which is 2. So we need to get two integers, which when added will give us 2, when multiplied will give us 1, and that will be 1 and 1. So we rewrite the expression and splitting the middle term into the two factors. So we have x squared plus 1x plus 1x plus 1. The next step, as we discussed last time, was to factorize the pairs. So when we factorize, what is common there is x. So we put it out, and then we have x plus 1. And in the second pair, what is common is 1, and we have x plus 1. And therefore, the expression becomes, here we have x plus 1 and x plus 1 are common, so we put it out. When we factor it out inside the bracket, we have x plus 1, and this will be equals to x plus 1 squared. So you can see our expression x squared plus 2x plus 1 is a perfect square because it can be written in that form. Then, so make x squared plus 4x a perfect square. Now, the task here is to make x squared plus 4x a perfect square. We will do that by completing the square. So to complete the square, we need to add half of the coefficient of the middle term whole squared. So half of 4 is 4 over 2, which is equals to 2 squared. This is equals to 4. And therefore, the expression, the complete square becomes x squared plus 4x plus 4, which is actually equals to x plus 2 whole squared. Supposing you are told make t squared plus 18t a perfect square. Following the procedure, we will say t squared plus 18t plus half of 18 over 2 whole squared will be the perfect square. So this will be t squared plus 18t plus 9 squared. And this can be written as the square of t p plus 9. Make p squared plus 13p a perfect square. To do that, we need to complete the square. So we simply add a half of 13 whole squared. So plus 13 over 2 whole squared. That will be equals to p squared plus 13p plus 6.5 squared. And therefore, this will be the square of p plus 6.5. Supposing you are given a fraction, let's say as the coefficient of the middle term, s squared plus a half s, and you are asked to complete the square. So you follow the same procedure. You say you need to add half of the coefficient of the middle term. So a half, that means divide by 2 whole squared, which will be equals to s squared plus a half s plus 1 over 4 squared. And therefore, this will be a square of s plus 1 over 4. And so you can see it's a perfect square. Now, supposing the question has a minus sign for the middle term. You are given, make a squared minus 2a a perfect square. So again here we have to add the square of a half of the coefficient of the middle term. So we will say plus negative 2 over 2 whole squared. So which will be a squared minus 2a plus negative 2 over 2 is negative 1 squared, which becomes a squared minus 2a plus 1. Negative 1 squared is equals to 1. Now, you may wonder, now this one becomes a minus 1 whole squared. I was about to say, you may wonder how I arrived at this so fast. Now, for any perfect square, you will find that if, for example, I have x squared minus 4x plus 4, which is a perfect square. To get what this is a square of, we'll say the first term here will be, this one will be the square root of this. So we get square root of x squared, which is x, and then the sign remains the same, so it becomes minus, and then square root of 4 will give us 2. So this is a square of x minus 2, That is how to determine what it is a square of. Let's do that again. Supposing you are given x squared minus 6x plus 9. So to get what this expression is a square of, is a perfect square, and it is a square of x minus 3. So it can be written as x minus 3 whole squared. How did I get that? First, this one is always square root of the first term. This one is always a square root of the third term. The minus sign remains minus sign. So for a perfect square, this term will be the square root of the first term, and the second one will be the square root of the first term. If this sign was positive, then that also will be positive. So that is how to go about getting what it is a square of. I'll give you the last one. Supposing you are given to make r squared plus 2yr a perfect square. Now again, we follow the same method. Here, the coefficient of the middle term is positive 2y. So we will say, we simply add the square of half of the coefficient of the middle term, 2yr, plus a half of 2y, that is 2y over 2, then you square that. And when you do that, you get r squared plus 2yr plus y squared. Now this is the square of r plus y whole squared. So basically that is a simple procedure. All you need to remember is to make a number, to make any given expression a complete square, and that is what we are calling completing the square. You add to the third term, and the third term will be half of the coefficient of the middle term squared. So I need to put that in writing. To complete a square where the coefficient of the first term is 1, you add half of coefficient of middle term squared. So you add half of the coefficient of the middle term squared, and by doing that, you have completed the square. That brings us to the end of this lesson. Thank you.